In this video, we'll learn how to use Pascal's triangle for binomial expansions. Now remember, binomial expansions are things looking like this: a plus b to the power of n, where n is some positive integer or whole number. Now here's the idea. If we need to find all the terms of this expansion, we need to draw Pascal's triangle to the n plus 1th row. So I'll just write that down. Draw up to, or I should say down to, the n plus 1th row. And let's see how this works. Here's an example. Let's say we wanted to find all the terms of a plus b to the power of 4. Well, to begin with, what we'll do is, just as we said earlier on, we're going to draw Pascal's triangle to the 4 plus 1th row. In other words, 5th row. So let's go ahead and do that. We have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, and 4, 6, 4, and 1 on each end. And let's just check that we've got all the rows we need there. We should have 5 rows. That's 1, 2, 3, 4, 5. Good. We now have the 5 rows we need. Now, one thing that we've learned is that a plus b to the power of 4 is equal to the binomial coefficient 4, 0 times a to the power of 4 plus the binomial coefficient 4, 1 times a cubed times b plus the binomial coefficient 4, 2 times a squared b squared plus the binomial coefficient 4, 3 times a b cubed, and I'll just write it under that because I'm running out of space here, plus the last term, binomial coefficient 4, 4 times b to the power of 4. Now the way that Pascal's triangle will help us here is the fact that this first binomial coefficient, 4, 0, is equal to this number here. In other words, the first number we see on that 5th row. The second binomial coefficient, 4, 1, is equal to 4. The third binomial coefficient is equal to 6. The fourth one is equal to 4. And last but not least, the 5th one will be equal to 1. So in other words, what Pascal's triangle is allowing us to do is just to avoid all calculations. We can read the binomial coefficients directly off the triangle. So I can go ahead and say that this is equal to 1 times a to the power of 4, so that's just a to the power of 4, plus 4 times a cubed b, plus 6 times a squared b squared, plus 4a times b cubed, plus 1 times b to the power of 4, so that's just b to the power of 4. And there we have it. Let's look at another example. Let's say we needed to find all the terms of a plus b to the power of 5. Well, following the same method, in this case we would go to the 6th row of Pascal's triangle. So let's start with that. That would be 1, 1, 1, 2, 1, 1, 3, and 3 with 1 on each end, 4, 6, 4, and 1, and 5, 10, 10, 5, and 1 on each end. Now, we know that a plus b to the power of 5 is equal to 5, 0 times a to the power of 5 plus 5, 1 times a to the power of 4 times b plus 5, 2 times a to the power of 3 times b squared plus 5, 3 times a squared times b cubed, and I'll write the other two terms below, plus 5, 4 times a times b to the power of 4, plus 5, 5 times b to the power of 5. And here, once again, Pascal's triangle is going to be a really great tool to find all these binomial coefficients. 5, 0 is equal to 1. 5, 1 is equal to 5. 5, 2 is equal to 10. 5, 3 is equal to 10. 5, 4 is equal to 5. And 5, 5 is equal to 1. So we can go ahead and write the answer. This is going to be equal to 8 to the power of 5 plus 5 a to the power of 4b plus 10 a cubed b squared plus 10 a squared b cubed plus 5 a b to the power of 4 plus 1 times b to the power of 5, that's just b to the power of 5. And there we go. That's how we use Pascal's triangle for binomial expansions.